So we're going to take a closer look at that rotation that was shown in the last video around the carbon-carbon bond of ethane. So here is ethane, which of course is just CH3CH3, and the skeletal structure is a line. It's only 2 carbons connected by a sigma bond. But if we want to get more of a 3D feel for how the molecule looks, we're going to start drawing what's called a perspective drawing. And so when I'm looking at this from the side, I see 2 hydrogens, and I'm going to notate these in blue, sticking up directly across from one another, and I'm going to draw those in the plane of the screen here. And then I'm going to show going into the board, or screen, excuse me, and coming out of the screen, these white hydrogens. So here on the dashed wedge are 2 hydrogens that I see going into the screen, and then the other 2 hydrogens I see coming out of the screen towards me. And so this is what how we would represent the 3-dimensional nature to capture the tetrahedral geometry of each of these carbons. What I'm going to show you on the next slide is going to be looking down the carbon-carbon bond. If we were to take the structure on the left and rotate it, and we could look at it down this carbon-carbon bond from the front, that's going to be the angle that we're going to use to draw some more pictures. Another way that we might represent the ethane molecule to capture more of a 3D perspective is to draw what's called a Newman projection. And so we're going to look again down this carbon-carbon bond. And so to draw a Newman projection, the first thing that you do is you actually draw a circle. And in that circle, we're going to draw our front carbon. So the front carbon is actually right here in the middle, so that would be this carbon here. And then what we're going to do is draw the blue hydrogen that we see sticking up. That's this one in the front. The white hydrogen that's off to the left, or excuse me, the right, and then another white hydrogen that's off to the left. Then what we want to be able to do is to capture what's going on in the back carbon. And we're not going to actually draw the back carbon itself. What I see sticking up is that directly in behind the blue hydrogen in the front, I see another blue hydrogen sticking up out of the back. That's this one. Off to the side here, we can't see it because my hand is in the way in the picture, but there's another white hydrogen there. And then a hydrogen sticking off to the left, that would be this one here. And so what we have drawn here is called a Newman projection. And in this Newman projection, we're really interested in the angle between these 2 hydrogens here. You can see that it's the same angle as would be between any of the these 2 white hydrogens or the 2 white hydrogens on the left. But what we're going to do is use the blue hydrogens to sort of track this angle as we go through a full rotation about the carbon-carbon bond. Right now, I would say that this angle, which is called the dihedral angle, is 0. They are right one on top of one another, so there's a 0-degree angle there. Now if we begin rotating the front carbon, and so notice I'm leaving the back carbon alone with the blue hydrogen still sticking up in the back here. But if we rotate this guy out, and now we draw a Newman projection, it's going to look a little bit different. So we're going to still have in the back sticking up a blue hydrogen and then 2 white hydrogens off to the left and right. But then in the front, now I see a blue hydrogen off to the right, and then the 2 white hydrogens are like this. The angle between these two blue hydrogens that we're tracking is now 60 degrees. And so by rotating the front carbon, we've changed the angle between the two blue protons that we're keeping track of. And remember, this is called the dihedral angle. So if we keep rotating, and now we do another 60-degree rotation, and we draw a Newman projection, we're going to see in the back, once again, blue hydrogen sticking up, white hydrogen off to the right and left. And now I see this type of drawing, but this time it's the blue hydrogen that's over here, and there's two white hydrogens here. The angle between the two blue hydrogens has now become 120 degrees. We're going to keep going through this process. We're rotating again. In the back, we see the same thing. This is being held constant the entire time. But in the front, we now see a picture like this with the blue here and the two whites. Dihedral angle is now 180 degrees. Okay, again, we've rotated. We're going to draw the Newman projection looking down the carbon-carbon bond. In the back, that's still the same. But what I see up in the front now looks like this, where I have the blue hydrogen over here, the white up here, and here. And so now the dihedral angle, you could think of it as being 240 degrees. I know technically going this way, we could say the dihedral angle, well, that looks like that's back to 120. But we're going to follow it around in a full 360-degree rotation. So we're actually going to keep going in the forward direction. So we're going from 180 to 240. And one more time. Let's draw this Newman projection. In the back, we still have the same orientation. But on the front, I now see the blue off to the left and the two whites. The dihedral angle, whoops, we're going to go all the way around. And so it went from a 240 to a 300-degree dihedral angle. And now we're back to this one that we started with. But instead of calling it a 0-degree dihedral angle, this time we're going to call it a 360. And we'll talk about why we're doing it this way here in just a few minutes. So once again, we have the HH and the two whites off to the right and left, and we're going to call this a 360 dihedral angle.